Welcome. Synergy is pleased to present to you their final design for solar carports at PS4 at SDSU. Purpose of this project is to mainly reduce dependence on external sources of energy. By that, the university's bill would be lowered. Also, it will provide shade for parked vehicles. Lastly, achieving the goal of leading a sustainable campus. This design follows the code requirements of ASCE, ACI, AISC, and CBC. My name is Anas Al-Haddad. I'm an environmental engineering student and I was a project manager.
Hello, my name is Khalil Abdul Sattar. I am a civil engineer and I am responsible for the construction part of the project.
Hello, my name is Reem Hamid. I'm a civil engineering student and I was in charge for the solar panel design.
My name is Tarek Al-Hashmi. I'm an environmental engineer student and I was in charge of the sustainability and cost estimates of this project.
Hello, my name is Abdul Mohsen Al-Rashid. I'm a civil engineering student and I was in charge of the structure analysis.
Hello, my name is Anwar Ibrahim. I am a civil engineering student and I was responsible for material structural properties and structural calculations.
Hello, my name is Hassan Mohammed and I am an environmental engineer and I'm responsible for sustainability in this project.
The site is located on Canyon Crest Drive. It holds up approximately 255 parking spots. It is located on the 7th and 8th floor of the parking structure. After the site inspection was performed, possible column attachment spots were marked as viewed on these images.
One of the main sustainability aspects in installing solar panels in parking structure 4 is saving energy and money mainly. Considering the fact that solar energy is a renewable source of energy, installing the solar panels will benefit SDSU in the long term. In order to determine the project will be sustainable or not, the team managed to gather data of parking structure 1 power generation with solar panel installed and the total roof area of parking structure 1 and 4. By doing that, the team compared the two parking structure sizes and assumed based on the available data what parking structure 4 power generation would be when the project is complete. Based on the data, parking structure 4 roof size area is bigger than parking structure 1, and by having an electrical meter usage of parking structure 1 per day and 1 per hour, the team made an assumption that once the project is complete, the parking structure would generate around 650 kilowatt per day based on the data given. This graph is presenting a solar panel power generation in PS1 and power usage.
For the design criteria, we needed to follow some specific codes. Some of the codes are the ASCE 710, which is for the minimum design loads for buildings and other structures, the AISC 360, which is the steel construction manual, the ACI 318-14, which is the building code requirements for structural concrete, and the CBC 2016, which is the California Building Code. The design of the solar panels must meet the following design requirements. We need to determine the PV panels per steel framing layout. We need to follow vehicular vertical clearance requirements. And we also needed to calculate dead load, live load, seismic load, and wind load and meet the required criteria. While designing the structure, we wanted to maximize the number of solar panels without blocking the sunlight or decreasing the number of parking spots. The design will consist of 6 canopies. The total number of parking spots will not be affected by those canopies, and the total area that will be covered is about 30,000 square feet. That is about 30% of the total area of the parking structure. The canopies can be built on top of existing poles due to their relatively lightweight, and that would ease the design of the structure.
Material structural properties play an effective role in any project. In this project, there are certain steel section characteristics that should be followed. For example, all base plates cap should be A572 grade 50. Also, the high strength bolt should be A325. Additionally, machine bolts and threaded rods should be used in this project. The machine bolts and threaded rods are A307. In addition to these steel aspects, there are a number of specifications with regard to concrete compressive strength. For instance, slab-on-grade has compressive strength of 3000 psi, while suspended slab beams, columns, and foundations have compressive strength of 4000 psi. Furthermore, the reinforced bars have the following characteristics: A. Number 4 diameter or smaller with a yield strength of 40 ksi. B. Number 5 diameter or larger with a yield strength of 60 ksi. Moreover, this project has a certain dead loads criteria. For example, the self-weight of PV panels and frames is 4 psf. On the contrary, life load is represented by allowance for maintenance construction, which accounts for 4 psf. Similarly, static load parameters play an influential role in this project. The static load parameters for this project are importance factor, soil profile type, distance from fault, seismic source type, response reduction factor, dumping, seismic zone, and ductility capacity. Finally, wind load specifications were determined according to ASCE by assuming basic wind speed of 110 mph, wind exposure type B, and occupancy category 2. The structural calculations for this project vary from simple calculation to the most complex one. Therefore, a software was used in order to determine the complex calculations. The software that was used in this project is STAD Pro. Initially, the life load was assumed to be 0 psf. On the other hand, the dead load was assumed to be 4 psf. Similarly, the column dimensions were determined to be 24 feet length and 19 feet width through the use of STAD Pro. Also, the type of columns and girders were assumed to be HSST 18 by 6 by 0.25. On the contrary, the type of the beams was assumed to be HSST 12 by 6 by 0.25.
As for the solar panel design, according to CBC, California Building Code, the solar panels will be placed for every 24 feet, which includes 3 parking lots. And the dimensions, width and length of each parking lot should be 8 by 19 feet. Additionally, the weights of the solar panels and the beams were investigated so that it follows the design criteria of CBC and ACI. Moreover, we use the V-shaped solar panel because it is quite cost efficient and it is one of the easiest solar panel structure to build. Furthermore, ACI was used to design the anchorage of steel canopy to the existing concrete parking garage and to check the capacity of the parking structure to resist these reactions. Provided below are the proposed canopy 1 to 6 for the design of this structure. The table on the left shows the number of columns, panels, and square footage area of each canopy. For canopy 1 and 4, the number of panels are 201. For canopy 2 and 3, the number of panels are 402. And finally, canopy 6 and 5 has 114 panels. The total number of columns of the canopies were 50 with total area of 30,000 square foot. In addition, there are generally 4 components in every PV system: solar panels, controller, batteries, and inverter. And you can see on the left side a representation of those components. For the installation part, the solar panel support structure are erected using heavier gauge structural steel columns and steel structural beams with light gauge purlins that support the solar modulus. These structures typically have a galvanized finish, and the foundation includes exposed concrete above grade to protect the columns from possible vehicle damage. The system design is highly site-specific.
In this slide, we have 3 different phases. We have design stage, planning stage and building stage. The first one will be design stage, and it's one of the most important stages. So during this process, we will be reviewing contract drawings and make sure all drawings matches the specs, have common sense of coordination. If there is any changes in drawings or legends, always make sure the design is within budget, otherwise it will become an issue and it can be change of order. And the second one will be planning stage, and then this is another major stage. The goal is to review all the material and inspect it to make sure it matches the contract and specs. Always make sure it is falling under design, contract, and achieving the vision of the project. Reviewing as well as the needs that needs to be applicable to the project in terms of CARP and EIN labels to all kind of machines, everything we have in there. And the last one will be building stage, which is the final stage. It's basically we will be reviewing all trades doing their job. We will make sure everybody is under a good safety standards, and we will make sure that trades will not be falling behind schedule or causing any delays, and always verify if the design is being met and it has been followed as instructed.
Overall, the purpose of this project was to reduce the external sources of energy, lowering the energy bill of the university, additional shed for the university, and to lead a sustainable way of life and campus as our main goal. Our recommendation to this project regards the canopies. The number of panels and images represent the canopies for the specific design is 6 to cover the maximum area of the parking. Our group would like to acknowledge San Diego State University for allowing us and supporting us to do this project. We also would like to thank the Civil, Environmental and Construction Department of San Diego State University for further supporting us in being successful. A strong thanks to Professor John and James for being our mentors in guiding us to the path of success. Also, our group would like to thank Professor Nancy Lacroix, Professor Ziad Bayasi, Professor Robert Dool, and Professor Julio Valdez, Alexandra Duncan for advising us during the project. We would also like to thank KPFF employees leaders who helped us with our work, namely Kyle Schellinger and Sean Walters, and our group for having a strong sense of teamwork and responsibility. All load values that we proposed were in correspondence to our assumptions and calculations. By that being said, any error in any calculations will lead to change some aspect of the project, such as calculations. Therefore, our project is based on numbers and not other corporations' calculations.